Okay, so we've had a look at direct proportionality and talked about what it means for something to be directly proportional to something else. Let's have a go at a couple of typical exam questions like the ones we did in class. So we've got question 5. In a spring, the tension, T newtons, is directly proportional to its extension, x centimetres. So the first thing I'd be thinking when I look at this question is, well, straight away we've got T newtons, and it's telling us that's directly proportional to x centimetres. So we can write our initial equation. It's got to be T is proportional to x. Sorry, I said that's an equation. That's not an equation. T is proportional to x. Okay, we now need to turn that into an equation, and we can use our trick of saying that, well, we can always replace this proportional sign with an equals k, where k is some constant that links t and x. So we can now rewrite our t is proportional to x as t is equal to k times x, where k is the proportionality constant. Okay, now we might be tempted to think we're done, but it says find a formula for t in terms of x. Well, we've got that, but it doesn't say find a formula for t in terms of k and x. So I think it wants us to replace this k. So how are we going to work out the value of k? Well, we're going to use this pair of values here, because it's telling us, it's telling us that when the tension is 150 newtons, so when T is 150, the extension is 6 centimetres. So X is 6 centimetres, and we can use that pair of values. So we can say that, well, T, that's going to be 150. When T is 150 newtons, the extension, we need K as it was, the extension is 6 centimetres. So this is going to enable us to work out K. Okay, we're going to divide both sides by 6, and we're then going to get 150 over 6 is equal to k. So we've divided both sides by 6 so that we can isolate k by getting rid of that times 6 there. Okay, so if k is equal to 150 divided by 6, k equals 150 over 6. Well, 150 over 3 is 50. I reckon this is going to be 25. So k is 25. Okay, so we've now got our k. We can now rewrite our equation. Our equation before said that t equals kx. But we now know what k is. So our final answer equation is going to be that t is equal to 25, which is k, times x. It's not right, times, sorry. 25x. So t equals 25x. Okay, 3 marks. Right, part B then says calculate the tension in newtons when the extension is 15 centimetres. Okay, this is worth 1 mark if we scroll down. Okay, so calculate the tension in newtons when the extension is 15 centimetres. Well, we can use our exact same equation again. So we can say that t is equal to k times x, but that was pretty pointless because we've worked out what k is. So our equation now, as we know from the last answer, is t is 25x. Now it's asking us calculate the tension in newtons when the extension is 15 centimetres. So we're just going to substitute this 15 centimetres into our extension value. So we'll get an equation that says t equals 25, which is our k, times our new value for the extension, which is 15. Okay, so t is 25 times 15. Okay, well t, let's put a t there. Well, 10 times 25, that's 250. If we halve, that's 125. So I reckon we've got 375. So 375 newtons. Newtons. Okay, so t, 375. Okay, right, what have we then got to do? Well, we now know k, and we've used the idea of substituting. What are we going to do next? Well, we've got to calculate the extension in centimetres when the tension is 600 newtons. So unlike the last question, where it gave us an extension and asked us to calculate tension, this time it's giving us an extension and asking us to calculate tension. Sorry, asking us to calculate extension. But the procedure is the same. So we use our same formula. That's t equals 25, because that was k. X, t equals 25 times x. So calculate the extension in centimetres. So this time we need to calculate the extension. We don't know this. When the tension is 600 newtons. So this time we do know 600 newtons is the tension. So let's put things in the right place. That's going to give us 600 newtons. 600 as the tension is equal to 25 times our extension. So we now need to rearrange for x. So hopefully we can see we've got to divide both sides by 25. And that's going to give us x is equal to 600 divided by 25. Okay, so 600 over 100 is 6. It's going to be 4 times that. That's one way we could look at it. So I reckon we're going to get 24. Okay, so x equals 24. If we're not sure, we could always have a check. 600 over 25. Bingo, 24. Okay, so x is 24 centimetres. Done. Okay, so that's a fairly standard question. We've got 3 marks for a start, bit of work to do, and then 2 lots of straightforward substituting. So 5-mark question. Okay, so let's have another look at, another one. We've got question 6. D is directly proportional to the square of t. Okay, so again, I'm thinking D is directly proportional to the square of t. D is not proportional to t. It would not be correct to write D is proportional to t, but it would be correct to write D is proportional to t squared. So this sentence here, D is directly proportional to the square of t, translates to this equation. D is proportional to t squared, the square of t. Okay, other than that, we've got exactly the same steps. We're going to use our little trick, and we're going to say that, right, I can replace this with equals k. So my equation now is D is equal to k, some constant, times t squared. D equals kt squared. But again, it says express D in terms of t. It doesn't talk about a k in there, so we better work out what k is. Okay, so again, we're going to use the pair of values that they give us to find out k, the proportionality constant. So let's do that. Okay, we're going to write D is 80. So D equals kt squared. When D is 80, so I can write 80, is equal to k, we don't know what that is yet, times t squared. Okay, so I've got t is 4. So if t is 4, t squared is going to be 16. Okay, so we've got 80 equals k times 4 squared, which is 16. So 80 equals 16k. Okay, right, so again we've got to rearrange. Hopefully we can see if we divide the right hand side by 16. Okay, we'll isolate k. So we're going to get k is equal to 80. Got to divide the 80 by 16 as well. We'll get k equals 80 over 16. Okay, right, I make that 5. 80 divided by 16, let's have a look. I've got to check. 80 divided by 16, bingo, 5. Okay, so we're all good. K is 5. Alright, okay, so K is 5. We can now rewrite our equation with K as a known. So we've got, what do we have? We had D equals KT squared. But we can now write that D is equal to 5. Because we just found K is 5, T squared. There's our equation. Okay, 3 marks, just like the last one. The only tricky bit, perhaps, was that we had to put D as proportional to T squared. Right, B. Work out the value of D when T equals 7. How many marks? 1 mark. Looks familiar, just like last time. So work out the value of D when T is 7. So we'll write out the exact same formula again. D equals 5T squared. Work out the value of D when T is 7. Well, let's substitute T. to find d. So we've got d, which we don't know, is equal to 5 times t when t is 7 squared. So we're going to put 5 times 7 squared. Okay, we're not going to put d equals 5 times t, 5 times 7, because our formula here tells us d is equal to 5 times whatever t is squared. So we want d equals 5 times 7 squared. Okay, so that gives us d is equal to 5 times 49. What's that? Half of 490, 245. So there we go, 245. We want 5 times 49. Bingo. 245. So d is equal to 245 watts. Don't like it that there are no units in there. Oh, we don't know. We don't know units, so that's fine. Okay, so this was equal to 245. Our answer is d equals 2, 4. Right, stupid pen. 2. Thank you. 245. That's supposed to be a 5. Okay. Right, C. Work out the positive value of t when d is equal to 45. So it's like the last question. This time they're giving us t. No, this time they're giving us d. Last time they gave us d. But we do exactly the same thing. Did I just say that wrong again? Last time they gave us t. This time they're giving us d. Can't remember whether I said that or not. Right, so we go again. Exact same equation. We want d equals 5t squared. And we're going to substitute in the values that we know, which is d. So d goes in here. This time we don't know t. So this might be slightly worse this time, but should be fine. We've got 45 is equal to 5 times t squared. Okay, so I'm thinking we divide the right hand side by 5 to leave t squared on its own. Divide the left hand side by 5 will give us 45 over 5. That's equal to t squared. Okay, so t squared is equal to 9. Okay, now why did it say work out the positive value? Right, well we've got to find the square root of 9 to find t. So if t squared is 9, then our final answer, t, is going to be the square root of 9. Okay, now this could have been two values. Okay, the square root of 9 clearly could have been positive 3, or it could have been negative 3. Okay, it's specifying the positive value of t, so we want 3 plus 3. So t is 3 for 2 marks. Okay, now this time it was 2 marks, probably because the rearranging was a little bit harder because you had to find a square root. Okay, but not much more difficult than the first example. Okay, hopefully they made sense. Okay, just to check, you could have a go at this question, question 7. Okay, so part A and part B are there, and obviously you can pause if you need to. So if I scroll down for you now, part C will be there, very similar to the ones we've tried. Okay, I suggest you have a go. Good luck.